Assalamu alaikum wa rahmatullahi wa barakatuh. So today I'll talk about slope fields. So the general definition just about slope fields is that in this graph you'll it's like it gives you the derivative at every single coordinate. In a way, you can see like the shape of the slope, or you can see like the whether the slope is positive or whether it's negative or whether it's undefined. So here you can just look at some places like over here the slope is just the slope at this coordinate is positive. It's resembling a positive slope. The slope at this point it's a horizontal line. It shows a slope of 0, and then slope over here it shows a negative slope, which is a slope that's going down. And so in slope fields we're usually given the derivative, which is dy dx, the derivative of y with respect to x, and the derivative that's given here is negative 2x over y. And so I have the table of values. So my first coordinate I have is 1, 1, and so my x value is 1 and my y value is 1. So if I were to plug it in negative 2x, so negative 2 times 1 over 1, which is negative 2. So at 1, 1, we have a negative slope. And just an example of a slope that is 0, just a common pattern. If you see at the y-axis, all the slope is 0. So 0, 2. So the x coordinate is 0. The y coordinate, the y value is 2, and so negative 2 times 0 is 0, and 0 divided by anything is just going to be 0. So you can see a horizontal line. And then at negative 2, 4, so negative 2 times negative 2, that's a positive 4, and then 4 divided by 4 is 1, and you can see a positive slope over here. So just to review one more time, if the line is pointing upwards, the slope is positive at that coordinate. If the line is horizontal, the slope is 0 at that specific coordinate. And if the slope is negative, if it's pointing downward, then the slope is negative. And the slope is negative at that specific coordinate. And the whole point of the slope field is that you can see the direction of the graph itself, or you can kind of sense you can sense the shape of the graph itself. So this one over here, it kind of looks like a circle. Just based on the slopes over here, you can see that it looks like a circle. So let's say we're given a question, except we don't know which one is the derivative itself. So the way to do that is that we can pick a specific point, like so let's say this coordinate over here, 2, 1. So at 2, 1, what we know over here, the line is pointing upward, and that means the slope is positive. So again, the slope is positive, but we don't know we don't know the number, we don't know whether we have a slope of 3, slope of 4, but just the general term is that if it's a slope of 1, it's gonna look like this shape, and it's gonna look like a 45-degree angle. If it's a slope higher, if the slope is greater in value, then it's gonna go up vertically. It's again like these coordinates, but don't get confused. It's not a undefined slope. So let's just take this coordinate over here, 2, 1. So I'll plug in here. In this equation, in this derivative, if you plug in 2, 1, so 1 over 2, which is the x value. Again, this will be negative 1/2, and the slope over here is positive at 2, 1. So we would cross that one out. And then at b, we have 1 over y. So the y is 1. So negative 1 over 1, and then like we said, the slope is is not negative, so I'm gonna cross that out. And then at d, so the slope here is going to be positive, but again, I said as if the slope becomes greater in number, the slope is not going to look like a 45-degree angle. It's going to go up vertically like these type of slopes. So that's why we're going to cross out D. And then just our final answer is just going to be C.